This is a problem from Leetcode.com called first unique character in a string. And the problem goes as such. Given a string S, find the first non-repeating character in it and return its index. If it does not exist, the first non-repeating character, then return -1. They have an example here, Leetcode actually, and the output is 0 because the first unique character in this string is L. That's the first character in this string that doesn't repeat again. It's the first unique one. And then in this example, love Leetcode, the first unique character is 2. The index of the first unique character is 2. So if you start at 0, 1, 2, then V is the first character that doesn't repeat again. And then here, every character in this string repeats. A repeats, B repeats. So you return an index of -1 because there's no unique character at all in this string. Anyway, if y'all ever watched me do these problems before, you know I like to think through the solution first. Maybe write it down, maybe not, but at least think through it in my head of how I would solve it. And then try to take that solution and apply it to code with data structures and algorithms that I'm familiar with from my experience or just from my studies. So just jump over to the code side. As you do these problems, you start to learn how to trade space for time complexity. So if you use space, oftentimes you'll see in these problems, you'll be able to reduce the time complexity by using space. And so what I can do here is use use a map to store the frequencies of the characters in this string. And by storing the frequencies of the characters in this string, I'll be able to easily look through the frequencies and figure out the first time that I have a frequency of 1. If I have a frequency of 1, that means it's the first unique character, or that means it's a unique character, and I need to find the first one and return its index. So by storing the frequency, it'll allow me to loop through one time, store the frequencies, instead of every time I look at something, I go and check everything over again in the whole array. Like, it's just really inefficient. So in JavaScript, you can use what's called a map, or you can just use, for certain situations, you can just use an object and use it as a map. So what I'm going to do is actually just use an object as a map this time. I'm just going to use an actual object and use the keys in the object as I would a map. So let's set up a frequency map. That's my map. And so what I'm going to do, like I said, is I'm going to have a loop again. I should have copied the loop from last time, so I don't have to type this over again, but it's fine. So y'all saw me do a loop the last time. I'm doing another loop. If you don't know what loops are in JavaScript or loops are in general, that's something to try to learn before you start to do these problems, of course. So I'm looping through. So I have a loop here. And so what do I want to check here? So first, I want to populate this frequency map with duplicates. So what will happen is, as I loop through this, what I need to check first is I need to check if my frequency map already has this. So let me just go back. S, as we know, when you loop through something, you can find the item in a string at that interval that you're at, I, by using this syntax, S, and then these open bracket, I, close bracket. So let's just get that out the way so you understand that. But what I can basically say is, I can do the same thing on the frequency map and say, do I have something inside of this frequency map already for SI, which is the character at this index that I'm on? If I do, then I basically want to take SI and increment it. And this is going to make more sense in the next line. If I don't have anything in here, it's no value at this key in frequency map, then I actually want to take it and populate it. I want to set it equal to 1 because it's going to be the first time that, and you actually can reverse this to make it make more sense to you. You can say if there is nothing in here, then put the 1 in there. You can do it like that, but I just did it the other way. So yeah, so I'm going to set it to 1. I'm going to set a value in it. And so the next time I find a duplicate, it's going to know something's in there here. and then it's going to just do plus plus, which is basically going to add 1 to whatever value's already in here. So by doing this, when I loop through the string here, I'll loop through, I'll say, is something in my frequency map already? If so, add 1 to it, because that means I have more than 1. If it's the first time I've seen it, just make it equal to 1 to set this key in the frequency map. So this code will result in an object that has a key for every single character in the string, and it will have an associated number, which is the frequency of how many times that character has shown up in this string. So once I have this, now I need to find the first unique character that's in this string. So how can I do that? One of the things people get tripped up on is how to find the first unique character. They try to like loop through the frequency map itself to find it, which is not the best way. The best way is to go in the order of the string, because you want to find the first one and you want to just break out then. You don't want to waste time looking at stuff that you don't need to look at. You need to go in order, because you only need to find the first one. Once you find the first one, don't worry about processing the rest of the stuff. Process till you get to the point that you find your answer, and then get out of the problem. Like, you want to optimize your solution. So what I can do is simply just loop again here. So I'm going to loop through this again, and I'm basically going to say, if my frequency map has this in it and it's equal, the value of it is equal to 1, that means I just found my first unique character in the string, because its frequency is equal to 1. That means it's unique. It's only happened one time in the string. It only showed up one time. This character, which is this. This is how you pull the character out when you're looping. If I find that, then I need to return the index. Since I just simply looped this string again, I found the index. And this part right here is the biggest. Like, this seems like a really easy problem, but a lot of people mess up on this. I promise you. I interviewed people with this problem, like, I don't even know how many times. And people think it's super easy. They get through this part pretty easy. And because they're nervous or whatever the reason is, they didn't maybe not have seen this problem before, they just screw that part up. And then after that, if I don't find anything here, I don't find anything that equal to 1, that means there's no unique characters in the string. There's nothing that has a frequency equal to 1. So like my problem says, if it does not exist, return -1. So I'm going to return -1. This looks good to me. I don't know if I'm going to do it this time, but usually what you would maybe have to do in an interview setting, especially, they may not allow you to run this. They may have you just in a notepad. So you might actually have to trace through this code line by line with the interviewer. And it's probably something you should get in the habit of doing anyway. So I'm going to run this and see if it works. Yep, it worked. So I got all these cases right. ABB, that should have gave me -1. And then this one should have gave me 2. So that worked. I think I'm going to try to run it against Leetcode now and see what I get. Basically running it against all the other submissions in Leetcode. But it beat 76%, which is actually pretty good. It's about the size of the input and making sure your algorithm is optimized for scale. When the input scales up, when the size of S scales up, does your algorithm fall over, or can it run smoothly? And so let me go back to the big O complexity, and then I'll probably maybe answer some questions or something, and then I'll be done. So as opposed to my last solution, now I loop through the string once. So it's called the length of this string n, s dot length. Let's call it n, for instance. So this takes big O of n time complexity to run. I literally loop through the length of s. Then I loop through the length of s down here again. I'm just doing n operations here plus n operation here, not times n operations here. So that's 2n and not n squared. So 2n in big O notation will reduce down to just n. So this actually runs in big O of n time complexity. Basically, however long the string is how much that it will run. Basically, in space complexity, since now I have a frequency map that grows with the size of s, the length of s, then my space complexity, it's also big O of n. So I hope that makes sense to people.